Today, I would like to share with you a research project entitled Sampling Phenomena Using Time-Based Modulation of Amplitude in Mobile Acoustical Heritage, proposed by Chen Kim Lim, Kian Lam Tan, and Abdullah Sawik Talib. Before I move on to the demonstration of the system, let me explain to you some basic concepts of the proposed method and also define the words. Modulation of time-based amplitude. Amplitude is defined as how loud or how soft a sound is. In this proposed work, we aim to modulate various volumes in different zones. When the user taps on different action spaces of the iOS screen, in order to form a sensorial experience in virtual acoustical heritage on mobile platform. This is a picture taken from Town Hall, which is one of the 911 UNESCO heritage sites in Georgetown, Penang. This picture is downloaded into 360-degree panoramic view in a cylindrical form. This figure also shows the panoramic view with sequence of 5 distinct zones, and the sequence of recordings of 4 sound effects according to its zones. As we can see in the picture, there are 5 zones which are from zone 0 until zone 4 as labeled from the left to the right. Each of the zones has specific sound effects. For example, the crowd crowing sound effect is available in zone 0 and zone 5. In other words, recording number 1 and recording number 5 are the same. There are some image constants that have been predefined. The picture with effect at 3876 pixels and the picture height effect at 460 pixels, as it is divided into 5 zones. Each zone is 775 pixels in width. In this proposed method, the percentage of the amplitude is represented by 0.00 as the minimum and 1.00 as the maximum. The modulation of amplitude is different at x-axis and at y-axis. The figure shows the estimation of the percentage of amplitude based on 4 times 6 time zones at both x and y-axis. The first diagram shows the modulation as the x-axis. The highest amplitude is at the middle point while the lowest amplitude is at both left and right end of one zone. At the y-axis, the highest amplitude is at the bottom of the zone, and the amplitude will increase gradually as the user taps from the bottom to the top of the zone. Sometimes, when it happens that there is an overlapping zone, the amplitude is changed according to the audio recording of the overlapping zone. This is because when the user taps on the different action space, the tapping gesture is detected to be in more than one zone. Therefore, the sound play will be in the ratio of the overlapping zones.
Hi, this is a project on modulation of amplitude in an acoustical heritage on mobile platform. I'm going to show you the modulation of amplitude at x-axis. After selecting the project, click Run. When the view did load, you'll be able to see the Town Hall view which falls in Zone 4 and playing the audio recording of crow cawing. I'm going to first show you the overlapping effect, so I'll have to clear the terminal to show you the result. As the user scrolls, we'll be able to listen to different sound effects. And 00 here means there's no overlapping zone. And we scroll again, we'll be able to listen to C wave sound effect. And 01 means there's an overlapping zone between zone 1 and zone 0. As we scroll and scroll, the terminal will show the result of overlapping zone. And zone 4 is the last zone in 360-degree panoramic view. And we are done with scrolling gesture. Next is the tap gesture of modulation of amplitude at x-axis. 0.8 is what we get from tapping at the rightmost of the display screen. After clearing the terminal, let's try tapping somewhere in the middle. And 0.3 is the result. When we tap again, the third time is around 0.2. Let me show you another few times of tapping The percentage of amplitude play will be different from one spot to another spot depending on which zone the iOS display screen stops. We are now done with manipulation of x-axis, and let me stop this application and let's move on to y-axis. So I'll select my y-axis folder and select the project and then run the program. Build succeeded. So the screen will show the same town hall picture. Let me first clear the terminal, and I'll skip the overlapping part and proceed to the tapping gesture. This overlapping part is the same as y-axis. When I tap at the bottom, the percentage is around 0.02. Let's try again. And when I click on the slightly upper part from the bottom, we'll get around 0.13%. And when we click at the uppermost of the iOS screen, we'll get about 0.98%, which near to the perfect 1.00. And as we go on and on, we'll get different amplitude of the audio plate, and the amplitude will increase gradually as we tap from the bottom to the top. And that's the end of the demo, and I should be showing you the real program, which I have not separated them out into X and Y axis. Let me select the combination file and show you the real one. And when I run the program, and let me clear the terminal again. Let me scroll to one of the zone on random basis. And when I tap on it, it shows a percentage of X, which is around 0.2, and a percentage of Y, which is around 0.5 on our proposed method. If we try again, scroll and scroll and scroll, and tap somewhere, let's say here, we'll get around 0.2% on y-axis and 0.02% on the x-axis. So that's all, and thank you for watching our demonstration.
From the result of the evaluation based on 10 sets of data, the modulation of amplitude at x-axis decreases as the tap is farther away from the middle point. As we can see that the percentage of amplitude obtained varies from one another here. Next is another set of experiment here with the modulation of amplitude at y-axis. As a user taps from the bottom of the screen to the top of the screen, the amplitude increases gradually from bottom to the top also. Therefore, the proposed concept of integrating the modulation of amplitude in 360-degree acoustical heritage on mobile platform through the action space of the iOS screen has proven a significant sensorial experience for the users.